Hello and welcome to Smart Interviews. In this video, we'll solve a problem from LeetCode. The problem is called most frequent subtree sum. You can find the problem link in the description below. I highly recommend you to pause the video over here, open the problem statement, read it, understand it thoroughly, and try to come up with a solution on your own. Okay, let's get started. So the problem says that you're given the root of a binary tree. You have to return the most frequent subtree sum. Let us first try to understand what is a subtree sum. The subtree sum of a node is defined as the sum of all the node values formed by the subtree rooted at that node, including that node itself. If you look at the given example, the first example contains 3 nodes. So basically it contains 3 subtrees. The subtree rooted at 5 will have the nodes 5, 2 and minus 3, giving a sum of 4. The subtree rooted at 2 will have the node only 2, giving a sum of 2. The subtree rooted at minus 3 will have the node only minus 3, giving a sum of minus 3. So if you see, the sum that we have got so far are 4, 2 and minus 3. Each of them are occurring exactly once. The problem also says that if there is a tie in the maximum frequency, you should return all the values with the highest frequency in any order. So in the first example, all the 3 subtree sums are occurring exactly once, so we'll return all of them as the output. Hence the output is 2, minus 3 and 4. Note that the order of this output does not matter. If you look at the second example, again we have 3 nodes, that is we have 3 subtrees. Subtree rooted at 2 will have a sum of 2. Subtree rooted at minus 5 will have a sum of minus 5. Subtree rooted at 5 will have a sum of 5 plus 2 plus minus 5, which is 2. So if you see, the subtree sums are 2, 2 and minus 5. So 2 is repeated twice, making the subtree sum with highest frequency. So we are going to return 2 as the answer. Let us try to understand this better with another example. Let us say you were given this example. If you see, this example has 9 nodes. For the problem statement, we need to figure out 2 things. First of all, we need to figure out the subtree sums for every subtree. Secondly, we need to understand the frequency of each subtree sum so that we can find the subtree sum with highest frequency. So there are 2 parts. The first part is, as discussed, we need to figure out a logic to be able to find the subtree sums. The second part of the solution will require us to somehow figure out the frequencies of these subtree sums, and from there we should be able to find the sums with the maximum frequency. Let's try to focus on the first part. If you take any node, say if you take this node, its subtree sum will be the sum of the left subtree plus the sum of the right subtree plus the sum of the current node. If you take this node, its subtree sum will be sum of left subtree plus sum of right subtree plus the current node's value. Now if you observe this, it will be very helpful for us if we try to do this in a bottom-up fashion. So the moment we reach here, we can say that the subtree sum is 0 because it's an empty tree. Again from here, we can say that subtree sum is 0. Now for this node, the subtree sum becomes 0 plus 0 plus 2. So we got the subtree sum as 2. And from this, we can return 2 so that this node can find its subtree sum. Again, when we iterate on the right side, we'll get subtree sum of 0 from here. We'll get subtree sum of 0 from here. And for this node, the subtree sum becomes 0 plus 0 plus minus 6, which is minus 6. And we return minus 6 from here so that the parent node can find its subtree sum. So now for this node, the subtree sum will be 2 plus minus 6 plus 8, which is nothing but 4. And so on. Let's do for one more node. So we'll be returning 4 from here. So for this node, we have got the left subtree sum as 4. We will get the right subtree sum as 0. So the subtree sum for this node becomes 4 plus 3 plus 0, which is nothing but 7. So in this way, if we do a bottom-up traversal, we'll be able to find the subtree sum for every subtree, for every node. That helps us figure out the first part of the problem. Second part, we need to find the frequencies as well. One of the most common solutions for storing frequencies by using a hash map. By using a hash map or by using a dictionary as per your language of choice. If you are not familiar with hash maps and dictionary, I recommend you stop the video over here. You go back, learn the basics of hash maps and dictionaries, and then again continue watching the video. So for our case, we'll be using a hash map with key value pair, where the key will be nothing but the subtree sum and the value will be nothing but the frequency. Of course, both will be of type integers. Now, the moment we found this subtree sum of 2, we store it in the hash map with frequency of 1. Same thing for this, we store in the hash map with a frequency of 1. When we got 4, we stored 4, 1 in the hash map. And when we got 7, we stored 7, 1 in the hash map. Let us continue that. For this node, we have got the subtree sum for the left part. We need to find the subtree sum for the right part. So let's continue. We'll go over here. Its left will return 0. We'll try to find the right subtree sum. We go over here. We go over here. We go over here. It will return 0. We go over here. It will return 0. So this subtree sum becomes 4. Before we return it to the parent, we store it in the hash map. Since 4 is already present in the hash map, we'll simply increase the frequency. So its frequency becomes 2. Now again we go to the right part. We get 0 from here. We get 0 from here. For this subtree, the sum becomes 0 plus 5, which is 5. Before we return it to the parent, we'll store it in the hash map. Sum is 5. Frequency is 1. For this node, the sum becomes 4 plus 5 plus minus 2, which is 7. Since 7 is already there, we increase its frequency and we return 7 to the parent. For this node, the subtree sum becomes 4. It's already present. We increment the frequency and we return 4. For this node, the subtree sum becomes 7 plus 4 plus minus 4, which is nothing but 7, which is already present. So we increase the frequency. So after both these steps are done, we are able to find the subtree sums and we are also able to store their frequencies in the hash map. Now the next step is how do we figure out that the subtree sum of 4 and 7 is repeated for most number of times, and we should return that as the output? We can simply iterate on the frequencies and find that 3 is the highest frequency. That will be our first iteration. Then we can iterate on the entries of the hash map. We can match which of them has the highest frequency, which is 3, and we can extract all of them into a separate list. That can be our second iteration. Alternatively, what we can do is, while populating the entries in the hash map itself, in that iteration itself, we can keep storing the max frequency. If we do that, by the time we populate the hash map, our max frequency will be 3. So we can skip our first iteration. We can simply iterate on the entire hash map. We can keep matching the values, that is the frequencies, with the max frequency, and wherever it matches, we will store that subtree sum in a separate list. So it matched here, so we will store 4 in a separate list. It matched here, we will store 7 in that same list, and when we continue, we see that it is not matching again. So to summarize, we are basically traversing the tree in a bottom-up fashion. In this traversal, we are finding the subtree sum. We are storing that subtree sum in a hash map along with the frequency. In the same process, we are also updating our maximum frequency. Once this is done, we only have to iterate on the hash map, extract the subtree sums with maximum frequency, put it in a list, and return that list as the output. I hope you are clear with the logic over here. I highly recommend you pause the video over here, try to get a deeper understanding of the logic, and convert the logic into code in your language of choice. Let's see how the code will look like for this problem. So let's say we'll try to write the code in C++. If you look at the function name is find frequent tree sum. It is accepting the tree node, and it is returning a vector int, which is nothing but the list of subtree sum, which is repeated most number of times. Now, as discussed, the first thing that we'll do is we'll create a map so that we can store the subtree sums and its corresponding frequencies. Also, we will declare a variable called max frequency, where we store the maximum frequency of the subtree sums. Instead of writing everything in the same function, let us modularize the code. Let us move out the main logic to a separate function. Say the function name is solve. We'll pass the root node, we'll pass the hash map, and we'll pass the maximum frequency variable. The expectation from this function is it will traverse the tree bottom up, it will compute the subtree sums, store them in the hash map, and at the same time it will also update the maximum frequency value. Instead of jumping into that function and trying to complete the code for it, for now we'll simply assume that it works and we'll continue with our current function. Always try to complete the current function before jumping into implementation of helper functions. So once the hash map is populated, we need a vector so that we can populate the answer and return. Now we'll simply iterate on the hash map using an auto iterator. We'll simply check if the frequency of the current element, the frequency of the current entry of the hash map, if it's matching with the max frequency, so we know it's a subtree sum which has occurred with maximum frequency. We should simply add it to the answer. For C++ vector, we use pushback. So it.first will be added to the answer. So this is how you can iterate on a hash map. It.first will give you the key, it.second will give you the value. In our case, the key was subtree sum, the value was frequency. Hence, we have used it accordingly. And at the end, we can simply return the answer. That's the main logic in the current function. Now let's try to implement the solve function. As discussed, in the solve function, whenever we are calling with a node, it will return that node subtree sum. That means the solve function's return type will be integer. We'll accept the root node. We'll accept the hash map of type integer, integer. And we'll also accept the max frequency variable. Now, the first thing is we'll find the left subtree sum. So for that, we'll call the same function again with the left subtree. Hash map remains same. Max frequency variable remains same. We'll do the exact same thing to find the sum in the right subtree. Hash map and max frequency variables remain same. Once we have got the left subtree and the right subtree sum, the sum for the current subtree is nothing but the value in the current root plus the left subtree sum plus the right subtree sum. Once we get it, we will push it to the hash map. As we are using C++, we can simply do hash map of sum plus plus. If the sum is already present in the hash map, it will increase its frequency by 1. If it's not present in the hash map, it will put it in the hash map with a frequency of 1. That's what this line of code will do. After that, we also discussed that we should update the max frequency. So our max frequency will be simply maximum of the already existing max frequency versus the frequency of the current subtree sum, which we can easily get from the hash map. And then we'll simply return the current subtree sum so that the previous node can use it to compute its subtree sum. Code looks great. What did we miss? It's a recursive code. We always have to write a base condition. We discussed that the moment we encounter null, it's an empty subtree, its sum will be 0. So we should return 0 from there. The code looks fine. Let's try to run and see whether it works or not. It's not working. For the first test case, we got empty output. Even for the second test case, we got an empty output. That means we did something wrong. Our logic is as per our discussion. We have created the hash map, we have created maximum frequency, we are updating them over here, and we are iterating on the hash map and populating the answer. Let's see if we can debug and find the issue. One simple way of debugging is to insert print statements. So after we have called the solve function, let us try to print the max frequency and see if it is populated properly. For the first example, max frequency should be 1. For the second example, max frequency should be 2, as we have discussed previously. So we are running the code, but we see that max frequency is printed as 0 for the first test case. Even for the second test case, it is printed at 0. It means that this value never changed. But we are changing it over here, right? Why did it not change? Because we have passed this value. We have sent this parameter to the function with pass by value. The changes done over here will not reflect in the main function. To do that, we have to pass this by reference. A simple way of doing that is putting an ampersand over here. Now that we realize there is one mistake in the code, we also realize that even this hash map should be updated because we are using it over here. So even that must be passed by reference. So this should also be passed by reference. So that's a mistake that we found in the code. Let's try to run and see. So now when you run the code, you see that both the test cases are accepted. Our std out is 1, that is this max frequency is being printed as 1. Our output is matching as well. It was given in the problem statement that the order will not matter. So we are getting all these 3 elements in the output. Same thing for the second test case. The frequency came out to be 2 and the element came out to be 2. So we can remove this debug statement and we can try running the code. If you see it's working for both the test cases, we can submit and see if it's working for hidden test cases. It's working, it got accepted. Also, if you're familiar with hashing libraries, you will know that in C++ we have 2 hashing libraries. One is map, one is unordered map. Here we have used map. The difference between maps and unordered maps are, in maps the keys are sorted. But for our use case, we are not doing anything specific to sorted keys. So it is okay even if we go with a unsorted map. The library name for that in C++ is unordered map. So we can simply use that and even that code should work. Let us see. So this is working as well. We can submit and try. And as you can see, it got accepted. So I hope with this problem, you learned how to convert logic into code. You learned that there are 2 hashing libraries in C++, maps and unordered maps. And you also learned that if your code is not working and your code is in sync with the logic, how you can go about debugging it step by step. See you in the next video. Thank you for watching. Please like, share and subscribe for more such content.